Welcome to lesson P3. In P2, we solved equations. P3, we're solving inequalities. A lot of the rules are going to be the same, and there's one really important difference. Let's talk about that. So a lot of the properties, when I say it's very similar to solving equations, all the properties are basically the same. There is a property of equality that looked very much like this. If A was equal to B and B was equal to C, then A was equal to C. Well, if A is less than or equal to B and B is less than or equal to C, then A is less than or equal to C. So same idea, works the same way. And then for the addition property, subtraction property, multiplication property, and division property, it's all very similar. If you add something to both sides of an inequality, then it will be the same on both sides, right? So if A is less than or equal to B and you add C to both sides, it's still less than or equal. Same thing with subtraction, same thing with multiplication and division, with one main difference. The main difference has to do with if you multiply by a negative. So when you multiply something on both sides and it's more than zero, so positive, then the inequality stays the same. If you multiply something that's less than zero, so negative on both sides, notice how the inequality symbol flips. Then the same thing happens with division. If you divide something that's positive, the inequality symbol stays the same. If you divide something that's negative, the inequality symbol flips. So the first thing we're going to do is solve an inequality. Again, this works very similarly to how you would solve an equation. We're trying to isolate the variable. So the first thing I'm going to do here is distribute the 3. You get negative 2k is less than 3k minus 15. Subtract 3k. You get negative 5k is less than negative 15. Then you divide by negative 5. Since we're dividing by a negative, that inequality symbol will flip. So k is greater than 3. Let's look at the next one. Distribute the distribute the 2 to start. So now you've got 12 is greater than or equal to 6n plus 2 plus 22. I would combine those before I do anything else. Next thing I would do is subtract the 24. I know it's negative, but remember subtracting doesn't affect the inequality symbol, so that's not going to change. So now you've got negative 12 is greater than or equal to 6n. The next thing you're going to do is divide by 6. It does not matter that that 12 is negative. You're dividing by a positive, so the inequality symbol is not going to flip. What you are going to do here, though, is flip the entire inequality around, because at the end now, the variable that I was solving for is on the right. I want it on the left. So when I flip it around, that will flip around the inequality symbol, right? It's not because I divided by a negative. It's not because I multiplied by a negative. It's because I wanted to flip it around so that way the n was on the left. Notice how the inequality symbol is pointing at the n. When I flip it around, it's still pointing at it. Okay. So here's a question in context where we're going to write an inequality and then solve it to answer the question. So it says a real estate agent earns a salary of $2,000 per month plus 4% of the sales, meaning they get that $2,000 no matter what. And then they also earn 4% of whatever they sell. What must the sales be if the salesperson is to have a monthly income of at least $5,000? Okay, so the thing we don't know that we're going to need to define is the amount of sales. So sales, the unit that we're measuring, sales is dollars. All right, so they earn $2,000 no matter what, plus 4% Make sure if you're using a decimal, that's not 0.4, that'd be 40%. 0.04 or 400ths would be 4%. All right, so then 4% of the sales is also what they earn. So that combined, they want to be at least $5,000. So that would be greater than or equal to 5,000. So that's the setup. Now we're going to solve it. I'm going to subtract 2,000 from both sides. And you get 0.04. X is greater than or equal to 3,000. And we're going to divide both sides by 0.04. And you get X is greater than or equal to, I'm just going to use my calculator very quickly. And you get 75,000. All right, 75,000. So that means the salesperson needs to sell $75,000 worth of real estate in order to make their goal of earning at least $5,000 as a paycheck income. All right, so some inequalities are not going to have solution, or they're going to be infinite solutions. So let's look at those scenarios. First thing I would do here is distribute the 7. So you have 7x is greater than or equal to 14 plus 7x. Just like an equation that has variables on both sides, I'm going to try to move in one direction or the other. So I'm going to subtract 7x to try to move variables to the left. But what ends up happening is they eliminate from both sides. What you end up with is a statement that has no variables at all. The question is that a true statement? Is 0 greater than or equal to 14? And the answer is no. So that means this is a situation where there is no solution. And if you were to put that on a number line, well, it's actually pretty simple. You would leave it alone. Let's take a look at this one. Distribute the 2. You get 2x is less than 2x plus 2 plus 3. Combine the 2 and the 3, you get 2x is less than 2x plus 5. Subtract 2x from both sides, and you get 0 is less than 5. All the variables are gone. That is a true statement, and that means it's infinite solutions. Okay. We're going to also talk about interval notation. So if you have an inequality, x is greater than a, on a number line graph, that means somewhere at a, there is an open circle, and then you're shading to the right. Okay. The interval notation is a way that you can express what's happening in the graph. Every interval has two pieces to it, a left side and a right side. On the left side of the interval, it starts at, so basically this interval, we're talking about what part of the graph is shaded, okay? So it's A on the left because it starts getting shaded at A. It's infinity on the right because it goes forever on the right. So for this one, the only difference here between the first row and the second row is there's a bracket around the A as opposed to parentheses. The only difference on the graph is that it's a closed circle at A as opposed to an open circle. So when I go to write the inequality, the only difference is that it's greater than or equal to instead of just greater than. Let's look at the next one. x is less than b. There's an open circle at b, and you're shading to the left. So when I write my interval notation, it's what's on the left side and then what's on the right side. What's happening on the left side here is it's going forever to the negative side. So it's going to be negative infinity. We are going to use a negative sign in front of the infinity to talk about going forever to the left. Up here, when it was going forever to the right, we used just infinity. And then on the right, so on the left side, it's going forever to negative infinity. On the right side, it stops at b. And because it's an open circle, because it's just less than, it's going to be a parenthesis around the b. For this one, the only difference is that there's a bracket around the b compared to the third row. So that means there's a closed circle at b. That's the right side. The left side is getting shaded completely because it's going from negative infinity on the left. The inequality, again, the only difference between that one would be less than or equal to b instead of just less than. Okay. Let's also talk about compound inequalities. There are two inequalities that are joined by and, the word and, or the word or. Okay. For an and statement, you're saying x is greater than -1 and at the same time x is less than 3. You can also write that inequality as a compound statement, as one statement. Ignore that, sorry. All right, basically what happens is you flip this one around. The inequality symbol flips around as well, and now the x is in the middle. So this statement is talking about all the x values between -1 and 3. Okay. The interval notation for that would be -1 on the left and 3 on the right. The other word is or. So this is saying all the x values less than -1 or all the x values greater than 3. Okay. So the interval notation for that, actually it might make sense to just kind of look at this on a graph. On a number line, I should say. And actually let me write this one up here. So let's take a second and go back. On a number line, this is what that first one would look like. X greater than -1. So you've got -1 and you've got 3. Open circles at both, and you're shading in between. This is essentially the opposite. You have open circles at -1 and at 3. The first part is going to the left, so you're shading up this way. And then greater than 3, so open circle at 3 and then shading to the right. So when you write the interval notation for this, there's two pieces to it. It's not one interval like this one is, or like what we talked about in the last slide. The first interval is, well, -infinity to the left, -1 on the right. And then the second interval is 3 on the left and infinity on the right. Then you're going to use this symbol called a union in between to say the interval notation needs both of these pieces. It's that part, those two parts together. So we're going to solve and graph the compound inequalities, express your answers using interval notation. So we're going to solve these separately. All right, and then because it's saying and, it's going to end up getting stuck together. So we're going to add 1 to both sides. That and is telling us what we're going to end up with. Add 1 to both sides, you get 3x is greater than -27. Divide by 3, and you get x is greater than -9. Okay, let's do the second piece now. Subtract 7, you get 2x is less than 12. Divide by 2, and you get x is less than 6. So it's two pieces. And then all you have to do is slap an and in between them. And that is your answer. If I were to graph that, you got your number line. Somewhere on your number line is -9. Somewhere to the right of that is 6. They're both open circles. This one, you're shading to the right. And this one, you're shading to the left. But they'll stop at both those circles. You're just shading in between the circles. If I were to write the interval notation for that, it would be -9, 6. Oh, I guess I could have used that number line or whatever. All right, and then let's look at the last one. It's an or statement. So that means I know they're going to be facing away from each other. So the first thing I'm going to do is just solve each part separately. Subtract 9 to start. I've got 3x is less than or equal to -12. Divide both sides by 3. And I have x is less than -4. On this side, we're going to subtract 1 on both sides. You're going to get -2x is less than 4. I'm going to divide both sides by -2. And you get x is less, I'm sorry, since we're dividing by a negative, it's actually going to be greater than -2. You seem to have an or in between it, and that's your compound inequality statement. If I go to graph it, somewhere on the graph is -4. It's an open circle there, and you're shading to the left. Somewhere to the right of -4 is -2. You're going to have an open circle there because it's just a greater than. By the way, you can absolutely have greater than or equal to, less than or equal to, which would be closed circles on the graphs of the number line for these compound inequalities. The interval would be -infinity, comma, -4, union, -2, comma, infinity. All right, don't worry about the word problems if they're on your note sheet. What I want you to focus on is being able to solve these inequalities and trying the practices. All right, so we'll have the rest of class time today. If you're done the notes, you can work on the practice in class today. Otherwise, you'll have time in class to work on it tomorrow. All right, then please reach out to me if you have questions while you're working, whether it's in class. You can jump on the breakout room. If it's outside of class, send me an email with a screenshot and I'll get back to you.